Welcome to Maputo, the capital of Mozambique. In Mozambique, only about 34% of the people have access to electricity. And to raise this number, a thermal power plant is being built here in Maputo. A thermal power plant, to be as efficient as possible, needs a very good cooling system. However, as Maputo suffers from water shortages, it's not ideal to use a limited drinking water source as a cooling source. So another option could be using reclaimed water. My three objectives for this project were: what is the feasibility of using reclaimed water for cooling purposes? What is the cost estimation for implementing water reclamation for cooling purposes? And what are the possibilities for public-private partnerships for this project? So I started by looking at two different options. One option that would be put by the current wastewater treatment plant that would treat the water and bring the water down to the power plant by means of a pipeline. And the second option that we would place downstream and that would collect the water from the Infulen River, treat the water and directly have the water at the power plant. In my first week I visited the wastewater treatment plant to see which treatment steps were there and in which state everything was and which extra steps would need to be taken in order to get the water to a good cooling quality. Downstream, as I didn't have any information about the water quality, I did some tests. I measured the hardness of the water, the pH and the salinity of the water. And the most important thing I got from these tests was that the water downstream is salty due to salt intrusion from the Maputo Bay. So this meant that if option downstream would be chosen, I would need a desalination process to get the water to a good enough quality. After this, 11 different treatment options were compared by the hand of a multi-criteria analysis, which looked at 5 factors: the cost, the land use, the maintainability, the efficiency, and the complexity of the treatment steps. And in the end, it turned out that the most suitable option was a treatment option downstream that would consist of a trickling filter followed by a reverse osmosis plant. So for the cost, I had to first design the 2 treatment steps. For the trickling filter, I looked at designing the size of the tanks, and then I had to look at the packing material, so whether I wanted sand, gravel, or plastic, which one was the most appropriate. And then for the reverse osmosis plant, I looked at how many elements I needed for a recovery of 80% and what type of elements I was going to put into my pressure vessel. And once I figured that out, it was possible for me to calculate the cost using literature values. For the third objective, I had to look at different possible investors. And to do this, I interviewed different people here. For example, someone from the DNA, the EDM, and the municipality of Maputo. And overall, the general thought was that there was quite a bit of enthusiasm for the project, except not a lot of people from the interviews were able to say that they could economically invest in the project. However, they did list more private and public possible investors, which could be interesting to look at in the future. So yes, I do believe that this project is feasible. The cost right now of using reclaimed water falls slightly higher than the cost of using potable water. But however, with the right investors and the implementation of new regulations, this cost could be brought down. And I really enjoyed doing this project here in Maputo for the past 10 weeks. I learned a lot about the culture in this very diverse city and its beautiful surroundings. And I would love to come back one day.